Welcome to the VMUG virtual event. I'm Nathan McMahon. In this session, I'm covering Avi Load Balancer with VCF and unleashing self-service. Hopefully you're all familiar with VCF and hopefully you're all familiar with the Avi Load Balancer. In this session, we're going to cover a little bit about how Avi works and how it's integrating with VCF and how those integrations are critical in order to be able to do self-service, in order to be able to do a complete walkthrough of upload an app on one end and have magic work the other end. When we're talking about VCF, it's all about automation, automating operations, automating workflows to the point where I just do that. I want to be able to go and deploy my application and I want it to just work. Under the hood, there's a lot of components that make this happen on the compute, on the storage, on the networking. So the magic of this is straightforward. I want to have this automation. I want to have this automated and single workflow. But let's kind of tease this apart a bit. When we look at the infrastructure and start talking about the VCF's infrastructure as a service, we have compute, storage, and network. And these are largely comprised of our vCenter with ESX, vSAN, and then under the networking, we have what's you're traditionally thinking of, we have layer 2, layer 3 with NSX. But networking is layer 2 through layer 7. Layer 2 through layer 3 is NSX, providing the switching, providing the routing, and all of these components along with this. But working our way further beyond this, and further up the stack, we get into the load balancing and the application delivery in these services. And this is where Avi comes into play, is providing that. So a lot of times we just look at networking and just think, I have connectivity. Layer 2, layer 3, I can connect the packet here, packet there, away we go. It means a lot more than that, especially as we start talking about deploying applications, not just spamming packets. So taking a step back with Avi and Avi's architecture. So hopefully you're all aware that Avi is a fully capable modern load balancer, capable of doing load balancing, ingress services, global load balancing, application firewalling, et cetera. All of these kind of functionalities that you expect. Under the hood, though, Avi is the load balancing choice for VCF. Avi is that VMware load balancer. Avi is based around this idea of load balancing as code and load balancing as self-service. It's software defined. It's baked around this cloud operating model, which is exactly what VCF is. And this is why it's so powerful and so potent, is that it's using the same model, a lot of these same architectures that VCF is using as well. So it fits in naturally, and it makes it very easy for us to just slide in and to be able to integrate with this. And that integration is what's really important. When you just look at a traditional load balancer, if that's going to be just a generic software load balancer or a hardware load balancer, what you have under the hood is that it's going to have a CPU, and that CPU is doing data plane as well as the control plane and management as well. So that CPU is just time slicing across all of these different services, which works to a point. But what happens is as you start scaling this out, you have these active standby pairs of load balancers. And again, these are just hardware or software, but you have these little appliances and you start stamping these out by the tens, by the dozens, by the hundreds, and it becomes very untenable. Instead, if you look at where all modern architectures are going, what we're instead doing is that we're decoupling the data plane from the control plane. So what that means is that we have this centralized control plane, which is going to be the Avi load balancer, right? That's going to be the controller of the load balancing. Now, the other half of this is going to be the service engines. These service engines are the data plane. So by separating the control plane from the data plane, what this means is that the Avi load balancer is not one or the other. It is both, but it's these two components. And by doing that like this way we have one point to manage. So I'm managing one infrastructure, one fabric. That fabric can simply grow or shrink on the fly based upon how much capacity that I need. If I need more capacity, we simply spin up or tear down more service engines as we have more capacity, rather than installing additional load balancing pairs everywhere we go. Why does this matter? Because what this means is that we have this centralized control plane. By having that centralized control plane, that means that I can do all management from one place. Now, in some legacy load balancers, they have this concept of a centralized manager. A centralized manager is effectively just a backup tool. It goes and reaches out to all of your little load balancers, all these little islands, and makes a backup copy. That's interesting, but not entirely that helpful, because the actual running config is on each load balancer. So who is the source of truth? The source of truth is each load balancer, and the centralized manager just has a backup copy. Because of that, that centralized manager really is not very powerful. It can't do much. It's just, hey, there's a backup. With Avi's model, we have this orchestrator model. So the controller is that what you're going to be managing. So you as the administrator manage the controller, and then the controller is then going to proxy your request and reach out and manage the individual service engines for you. What that means is that we don't have 100 load balancers. We have one load balancing fabric that happens to be larger or smaller. And this orchestrator can handle things like self-healing, auto scaling. So if you have 100 service engines in your environment, one of them fails, you simply lost 1% capacity in the fabric, in this fully active fabric. And why is this relevant? Because this takes us back into things like tying it into VCF. I'm not managing 100 load balancers. What you have is that with 100 load balancers, they're all individually trying to talk to each and every ESX host or all. No, my people talk to your people. So with this orchestrator based, the Avi controller knows that it can talk to NSX manager and say, here's the job that I want accomplished. I don't need to have each and every one of my hundreds or thousands of service engines making those requests. They make the requests. The controller is the one that decides for them, says, this is what I need. I will talk to the orchestrator for the compute, the orchestrator for the storage, the orchestrator for any of these components like this. So this is really important when we start getting into things like self-service. In order to manage and have self-service, that means that everything needs to work together. And by everything working together, I can't simply say, I want to go and talk to 100 load balancers. No, instead, I'm simply going to go and send an API call and say, hey, Avi controller, here's what's changed. You figure out what to do with this information. So the orchestrator, this Avi controller, is proxying for all of these service engines. It manages them, and you would just manage the controller. Now, this platform then provides us the orchestration, automation, auto scaling, self-healing, all of these capabilities. On top of this platform, this is where we're going to then go and deploy. We have these capabilities like load balancing, global or multi-site load balancing, application security, web application firewall, ingress services for things like Kubernetes. And because this is a control plane and architecture, what this means is that the controllers sit out of band all day and they have nothing better to do but just provide rich application analytics visibility to apply artificial intelligence into this to really just tease out, instead of saying, here's 5 million data points, here's one bit of really actionable information. So these individual service engines are full proxies. They're sending data back up to the controller. It's telling the controller, here's the status of everything, every client transaction, the logs, et cetera. And the controller can take that, ingest that, and then find something that's actionable in there saying, hey, here's something that we want to look at. This is something that might be wrong. This is something that's not behaving. So this model lends itself very, very well to that integration with VCF, because it's the same. You'll see that this is very similar from a functionality wise as how VCF behaves, how NSX behaves, how all of these individual components behave. And so this tie-in works really well. At a high level, from a customer value perspective, really comes down to this. There's a lot of stats, a lot of numbers, but Avi is an integrated stack. What this means is that all functionality is included with the Avi license. So Avi is licensed separately from VCF, but with the Avi license, all Avi functionality, load balancing, global load balancing, ingress, web application firewall, and application security, and WAP is also included. On the functionality side of this, we're able to scale to the most challenging environments, and we're able to handle the most capable environments that you may need, if that's going to be with SSL or functionalities like this or large environments. And the way that the whole architecture of this plays out, it's something that's very easy to manage. It's very easy to automate. That makes it faster and easier to manage. It means you can do more with less. It means that you have to put in less effort and less time. That means you're putting in less hours. That means less probability of failures. That means it's just a less brittle environment. So that's the core of what Avi is. Um, Now, taking this and applying this and taking these principles of software defined, this concept of self-service automation, yeah, that elastic load balancing, the analytics, et cetera. And now we're going to take that and we start twisting that and say, all right, now let's go and apply this and turn that back to VCF. So by applying that into VCF, Avi is natively integrated, full stack integration to be able to build out this complete private cloud. So as we look at build, operate, consume, and protect, on the build and operate side of things with Avi integration with VCF operations, makes it very simple and easy to deploy Avi via a single API. You can deploy Avi, deploy the controller, and then from there, the Avi controller will spin up the service engines, talk to NSX, go through that whole process of deploying the apps. And along with that, that means that we're going to be deploying the virtual services. So the first step in all of this is we need to go and deploy that infrastructure, which means we want to go and deploy Avi. We have some really nice tie-ins with things like SCDC Manager, and you're going to see as we roll forward over the next few months, you'll see that this is actually going to be changing and improving as we go, as new releases are coming out. So there's a lot of pretty exciting stuff that's coming right around the corner here with this. But right now, it's really easy to deploy Avi, which makes it kind of cool. Just knock it out there. Just boom, we've got a load balancing set up. It's up and running. It's ready to go. And you don't have to do anything. On the consumer protect side, from the consumption side with VCF automation, this is where we get into the actual self-service. We'll get to this a little bit more as we'll explore more of what Avi can do with this. But self-service via service catalog, and even deploying the load balancing as code via things like ingress or Kubernetes services. And protecting with these applications, once the applications are deployed, we want to protect them, provide this functionality, application security, API security, et cetera. So start a little bit with just kind of this journey with VCF. First off, Avi's been integrated with going all the way back more than a decade now, very tightly integrated with things like vCenter, so that it knows how to talk to vCenter. Again, my controller talks to your controller. The Avi controller talks to vCenter and provide all the manage the life cycle of, say, spinning up service engines, putting them into the right port groups, all of these tasks. Polling and exchanging information about the health of the applications themselves or the virtual machines underneath them. So all of this type of integration has been around for a very long time. With VCF as well, we've been very tightly integrated with this. And you'll see that as we're going forward, there's a lot of new features and functionalities that have come out with each version. And the roadmap for this is really getting more and more aggressive, and where there's just more functionality. There's a lot of things that are coming right around the corner. So we're pretty excited about where we are today, but also where this is going. And this is only getting easier to deploy, easier to manage, and it just makes the whole process be a very seamless workflow. So you saw in things like with VCF 5.2, building and deploying this, that's where you first started seeing some of the really tighter integrations around some of the VRA and some of these pieces with the self-service. And some of the latest versions now with VCF 9, as you go and deploy this, Avi now has things like VPC support. So we're inheriting and learning VPC support from NSX, pulling that in so we have the same multi-tenancy, the same VPC, all the way down the line, so that we are very much in line with and following along that same workflow. So we're deploying Avi. We're also doing things like from an administrative perspective, automatically managing the certificates, automatically rotating things like the passwords. So all of that is done automatically. So you simply are managing VCF. Avi is just a part of VCF. And that's kind of the whole point of this, right? You're managing one workflow. The multi-tenancy and the VPCs, this is some pretty cool stuff to be able to have it so that Avi automatically just ties right into this. There's nothing special that you need to do. And then along with that, if you want to have things like I've got different users, I want them to be in different isolated tenants, I want them to have different levels of access and security. All of that is just rolled right into Avi as well. So we're inheriting that. That's going to be for doing things like self-service, service cataloging, et cetera, as well as even things like if you're wanting to deploy and export all this config as code. Terrific. This is what this VPC admin can see, and this is what this one cannot, because they're in a different tenant. They have a completely different wall. They're on the other side of it. Yep, exactly as you'd expect. And really important about this is this unmatched visibility that Avi has. Avi is providing extreme visibility into the health of each application, but also down into the health of each client interaction with that application. How long it took, how long the content took to generate, what the client's doing with the site. So all of this information and all of this visibility and analytics can be upwards of something like 700 different metrics per virtual service, per application. And it depends upon what the application is. If it's HTTP with SSL, with WAF, with whatever features that you turn on, adds more and more robustness to the visibility and the analytics. Historically, this is something where you could just drop onto Avi and see this, and you could then go and troubleshoot. You could then go and see the health of these things. But by tying this back into VCF, though, now what you're going to see more and more is that information is already going to be exposed back into VCF. So it becomes just simply one single workflow, so that you're not having to exit out of one tool to go into another tool to see if the third tool is working. We want this to be one single integrated operation. And on the protect side, Avi's providing visibility into the client interactions, things like web application firewall. With a firewall says who can talk to who. This client can talk to that server. Check. Life is good. Avi is the last line of defense before we roll through the network and we hand off this application traffic and we hand it off to that destination application. We're full proxy. We're terminating SSL, terminating whatever the protocol is on top of this. If that's something like HTTP, validating it's a valid HTTP request. But we're also able to understand what the client is saying to the server and vice versa. If it's saying, hey, can you send me the database? That's probably not a good thing. It's sending some SQL injection attack. That's probably not a good thing. These are the types of things that Avi is able to protect against. Something like Log4j. That's not a good thing. Hey, let me just go and drop that across all 10,000 of our servers, and I can do that in seconds. Obviously able to classify who the users are, what they're doing, what they're saying, where they're going. So with all of that information, obviously able to protect the applications, protect the APIs, etc. And this is something that's all part of the native functionality of Avi. So there's no separate license necessary. If you have Avi, you have this functionality and you can light this up. And so that way, we're not just providing load balancing as a service. You can layer on top of this and have additional layers of security incorporated and included with this. So tightly integrating Avi with VCF. There's a couple of different elements to this. Let's talk first about the actually deploying of Avi. So we have our compute, our storage, and our network, right? All right, we're going to go and deploy Avi using something like VCF operations. And in the process of doing this, we're now going to say, let's go and fire up Avi, the Avi controller. So that's going to go spin up the Avi controllers. The Avi controller is now instantiated and is now part of this. And again, this can be done via single API. Once that's in place, now we can start working our way up the stack into things like the VCF automation. So now we're going to want to be deploying the applications, doing these kinds of functionalities. In the process of doing that, we're going to then go and say, let's go and build out our infrastructure. So we build out multiple VPCs, multiple tenants, place these users into the appropriate VPCs, and tie all that back into the structures and these orgs. As you do that, that information is all pushed back down into Avi. So Avi is aware of this. So now when you go through and use something like the catalog and say, I want to deploy the application, we know that this application for you is getting deployed in tenant one. You have these rights, these permissions, all the way down the line. So all of that is natively baked in, and Avi knows how to talk to all of the components, VCF operations, automation, talk to NSX to make all of this happen as one seamless workflow. Now, what if we don't have Avi in the middle of this? Let's say, what if we have just a generic load balancer that we, found, discarded on the side of the street, dust it off and try to plug it in? That's like having half a bridge, right? You start talking about, I want to have self-service. Self-service means that an application owner on one end says, I want to upload my application. On the other end, it should just shoot out, a couple seconds later. Well, mostly that kind of works. But every once in a while, oh, wait, you need to stop and open a ticket for this. Wait, you need to stop and open a ticket for that. You need to open up another ticket. That's not self-service. That's not automation. That's being half a bridge. That's not terribly useful. And customers are simply looking at this going, thanks, no thanks. That's not quite, that doesn't quite do it. Avi integration with this is really important because it's a completely consistent experience all the way across the board. So that your application owners don't necessarily even need to be exposed directly to Avi. They're just saying, I want to deploy the application. Maybe they give us additional information depending upon how they're deploying the app, if it's via catalog, et cetera. If you're looking at native integration with Avi versus something like a legacy load balancer, if that's going to be something like like an HA proxy or an Nginx or an F5 or anything kind of generic, like an older like that, they have no native integration. Literally, it's stop, open up a ticket because they don't integrate. They don't talk to, anything. They just, they're just kind of there. And so what you're going to find is that config drift, they're not consistent. If you have hundreds of load balancers sprinkled around and you want to go and make a change to the way that your application security behaves, you need to go and make that change in 100 different places. Not a good idea. That's a recipe for disaster. Every time you want to open up a new application, open up a ticket. Like, what's the point of self-service at that point? What's the point of I want this, immediacy? This should happen in seconds. Cool. Okay, Avi integration with VCF. Let's talk about application delivery here. Okay, so I'm going, let's say use the catalog, deploy my application, and I want to see this thing shoot out the other end, and life is good. There's a couple different ways that we can do this. We can use the VM service wizard. You can use VCFA via catalogs, and Kubernetes via the Kubernetes API. Today, the VM Service Wizard is layer 4 only. It's a pretty simplified workflow. It works really nicely, but it is a pretty simplified workflow. Moving forward, you're going to see this is going to be dramatically improved. So we're pretty excited about this and where this is going. If you want to get a little bit more robust with this, we're using VCFA with the catalogs and go and build out your own catalog. It makes it nice and simple and easy for an application owner to come along, click the button, answer a few data points, and voila, their application deploys. If we're getting a little bit more complex, we can get into things like the Kubernetes API, and then you have full power, full functionality, and you can get into that full DevOps pipeline. So for something like this, if we're doing something like VCFA and we're going to go and build out this catalog, obviously it can be natively integrated with this. So the automated provisioning, what that means is that I want to go and deploy my application. That's great, but I don't have a load balancer. That's the whole point of integration. That means that the Avi load balancer, that service engine, can automatically instantiate. You don't have one in your VPC. Hang on a second. We'll go and fire one up for you. And literally, Avi service engines will fire up. They'll drop into the right port groups. They'll integrate and talk to NSX all the way down the line so that, from my perspective, I just uploaded my application. The fact that the network wasn't fully there, wasn't ready, that's not my problem. I'm not going to open up a ticket. I don't need to. It should just work. That's the whole point of this. That kind of enterprise grade, just, self-service. So there's some cool and key things that are just happening in the background just behind all of this. So just a quick example of kind of walking through some of this and what this looks like is we're doing application deliver this way. So end to end, we just want to go and deploy an application. What would this look like? I need to go and deploy the application, the load balancing. So I'm gonna start with the VCFA using that user interface, just kind of going through that simple, layer 4 experience today. Again, this is going to be improved quite a bit in the near future. Build, deploy. I'm going to go and deploy a virtual machine. Deploy the virtual machine, define what it is, give it the appropriate parameters. Away we go. And now it gets more interesting. Now we're going to go and add a load balancer to this. We're going to say, I want to go and add a new load balancer. This is where we're going to go and define a few things about Avi and what this is going to be on the back end. So we're going to say which port, which protocol, what that might look like, if it's SSL, not SSL, these types of things. Today, again, this is layer 4, but you will see some pretty big improvements on this coming right around the corner here. As we go to and do this, on the back end, here's all the YAML that's being populated. This is what's all going to get fired off back to Avi. Under the hood, Avi is completely based around the idea of APIs and YAML. Now in the back end, once we've gone through and we've said, okay, we want to submit that, and now Avi goes through and is now going to create that virtual service on Avi. So in the back end, this is all created on Avi. It's all there. It's ready to go. If there's not much else that we would need to do. Pretty straightforward, pretty clean. Right now, it's not as potent and powerful as we want it to be, but we are getting there quickly. So keep an eye on that with the next releases. Now, if we're going to go through and let's say we want to create a catalog, this is where we could do layer 4 or 7. To kind of take a step back, layer 4 means we're just spamming packets. We get a packet coming in, we spam it to one of our servers. That's layer 4 load balancing. Layer 7 means that we're full application proxy. So we can terminate SSL, terminate the protocol, read into it, understand what the client is saying to the server, turn on acceleration, turn on better persistence. We are fully aware of what's happening here, and we can turn on better availability, better persistence, better accelerations. So given the choice, you always want to be layer 7. So there's two elements to this. First, we want to go and create that catalog. So we're going to go through, create that blueprint, everything that goes along with that. And then once we've done that, then we can actually deploy that. So this is just walking through creating a new blueprint, giving it a few parameters here. As we're going through and do this, we're saying where we're going to deploy this supervisor. We're going to go and drag and drop. As we drag and drop now through this interface, we're literally going and creating all the YAML, all the information about this. And this is what's going to get pushed out and deployed to Avi as well. So you're creating all those infrastructure, designing how it's going to be, and now we can go and directly modify that YAML and copy, paste, modify, drop that into that canvas. So we're building up this infrastructure of what this new application is going to look like. And we can go and populate that with the type load balancer, etc. And once we've got that in place, now we're pretty good to go. So we've got the Avi ingress, dropping this in the supervisor. So there's our fully populated blueprint. Now that that's there, now we can go back to the other side of this, the other half, which is from an application admin perspective, I want to go and deploy this application. So they're going to be the consumers of this and say, I want to go and deploy my Avi deployment, or I want to go and deploy my new app. And here's the parameters that they need to populate: the name, the port, the protocol type, whatever it might be. Populate that. Um, and now on the back end, as they're going and doing this, the virtual machines are going to spin up as the new application comes online. But the cool silent thing that's happening in the back end is, on the back end, if I need to have service engine on Avi, the load balancers on Avi, those will also be instantiating. And those that config gets pushed over to the controller pushes it down to the service engines. If it doesn't have service engines or they don't have enough capacity, it takes care of that for you, automatically instantiates the new ones, fully manages that life cycle, puts them into the right port groups, talks to NSX to make all of that magic happen there to allow the ports to talk to the right locations. And then the front end, it's ready to go. So there's my application. When we flip over to Avi, the Avi UI, we can see that this new application just came online and what that looks like. And away we go. The application owner doesn't necessarily need to know that Avi's behind the scenes, but they have full access to whatever information that you've given them. So whatever parameters that you want to go and populate into this, that's the functionality that they'll have available to them. So what if we're not using Avi in a case like this? What is that going to look like? Then what's going to happen is that your traffic is going to have to trombone out of VCF, go over to just a generic load balancer, and someone's going to have to open up a ticket and say, I want to create a virtual service. And they're going to have to go through all of these questions. Do I have a load balancer already that has connectivity? I don't support native integration with VPC. So do I have to manually create a VPC? How long is that going to take? Or do I create a new load balancer per VPC? What size do I need? I don't know. How big is this app going to be? I don't know. Each one of these steps is going to be another ticket. And so as you start going through this process, how many tickets are created? How many steps? With Avi, these are all just APIs. Avi's just shooting off APIs, talking to the environment around itself, learning about it, and figuring out what needs to happen, and away it goes. Right? I upload the application on one end, and on the other end, Avi has the configurations ready. It's done. So literally, it's going to take a few seconds to go and deploy this. It'll actually take you a little bit longer because in most cases you're spinning up your application virtual machines. Those may take a couple of minutes, but literally on the configuration side of the infrastructure, it's there, it's ready. It's just waiting for your virtual machines to fire up, and then 2-3 minutes later, you're good to go, and there's your app. That's what your application owners expect to see. That's moving at the speed of business. That's self-service. If you're not using Avi in this mix, then you're just kind of saying, oh, well, you could have it in a couple of minutes, or you could have it in a couple of weeks. What's the point? So kind of looking back in things like networking with Avi, Avi is directly tying into the VPCs, as I mentioned a couple of times. We're natively talking to components like the NSX component. For things like when we spin up a service engine, that new service engine, that load balancer component, it needs to be able to go and talk to these port groups. It needs to go and talk to these locations. It needs to talk to these servers and these segments. The NSX is handling all of that by talking to us to figure out which segments we need to talk to for each service engine so that I can talk to those applications. So effectively, the firewalling is happening, the routing is happening, the T0, the T1s, they all know how to get where they need to get to our virtual service that we're hosting. So that VIP address. All of that is happening automatically. These VPCs are all pushed down to us, and we're learning them from NSX. And by learning them, the cool thing about that is that now we know all about it. We know how to provide that segmentation. We know how to provide that multi-tenancy. If you don't have Avi in the mix, then what's going to happen? Then you're going to have a HA proxy size hole in your security story, because now you're just munging and merging all of your application traffic together and just kind of discarding the whole point of having VPCs, the whole point of multi-tenancy, the whole point of having separate failure domains. Cool. So it's kind of the with and without is pretty dramatic of what you're getting with this, that VPC awareness and that automated integration with the networking, so that the routing knows all how to get to where it needs to get to. In other words, that the T1, it knows that, hey, I just created a new virtual service over here on Avi. NSX already knows about it, knows what to do, knows how to get there. That routing is already ready to go. And if we need to go in, let's say the Avi service engine needs to go and talk to servers on web segment 1, that firewalling is already instantiated in place. If Avi needs more capacity, I said it was active service engines, active. Maybe I'll spin up a third one so I have 50% more capacity or whatever it might be. we're going and automatically talking to all the components around us so that we have all of that's instantiated so that we know how to get traffic to that service engine, and that service engine automatically can talk to those servers as well. So this is something that's happening with complete automation. Kind of switching gears a little bit here and looking at things like vSphere Supervisor and VKS. Obviously natively integrating as well across the stack, including with things like the supervisor. So we're the only layer 4, layer 7 load balancer for vSphere Supervisor. There is a NSX load balancer that does exist. It's very limited though in what it can do. So it can provide layer 4 load balancing in supervisor. It can provide some services in other areas, but it can't, if you're importing services from vCenter. So it has it has a whole lot of limitations as to what it can do and when and where. And that's the point, is that obviously only multi-tenant load balancer that's able to provide all of this, and that's fully integrating. Part of this integration is as we start talking about things like VKS and the Kubernetes, we have a piece called Avi Kubernetes Operator, AKO. AKO, basically what it's doing is that's listening on the messaging bus, and it's hearing, hey, this new application came online, it's deployed in this pod, etc. We learn about that, and that's forwarding that on via API back to the Avi controller. So the Avi controller knows what to do to provide that ingress or other services that we're providing for this. So as part of that integration, so that we can talk to into supervisor, we can talk into VKS, we can talk into these other environments. Today, Avi is easily installed into via standard add-on into VKS, and we install the AKO into each VKS cluster that you may have. This will change here pretty shortly, and this is actually going to become an automated process as well, which is really looking forward to. So keep an eye on new features, new releases, because this is something that's changing very aggressively as we keep consistently making this basically more of a seamless, integrated native experience. A couple of other things. Avi is natively integrating with Entria. And Entria is your default CNI for VKS. That means that we're providing things like node port local, which basically means we're able to provide, or I should say, we're able to bypass kube proxy in many use cases. And that provides you a pretty substantial improvement in throughput, speeds, and feeds as well. In VKS, yes, we're providing things like, do you provide ingress services? Yes, we do. We're providing that full layer 7 suite of functionality, including things like application security. That same application security we provide in virtual machines, we're providing that as well in container environments. So in any of these environments, if it's things like a web application firewall, or if it's client identification and classification to see who they are, where they're coming from, are they a bot? Are they a good bot? Are they a Google bot? All that information, all that capability is available to you. What are they doing? They're making some API calls. That an API call they should be making or should not be making. So very potent, very powerful, very capable functionality here that you can layer in, and you can have that be exposed to your clients, or you can have this be something that you just automatically say, if you deploy an application security just goes right with that. And that's just, this is what you're going to get. So it makes it very powerful. We can do this for ingress as well as gateway API if you have a preference on that as well. Additionally, some kind of cool things about this is that we're providing MTLS, or mutual TLS, or basically it's SSL authentication bidirectionally. So we're able to rotate the certificates. So I can do Istio. This is something that's going to be really important just because we'll be able to provide that complete end-to-end security. Along with this, we're providing kind of all that functionality, layer 4 through layer 7, all the way up and down the stack. Okay. So using Avi for VKS, simple to install, to throw down the AKO and have it be deployed in any of these clusters. This will become even easier going forward. So we've got some pretty cool improvements and enhancements to have this be even more native and more natively integrated. Provide some really good performance and functionality by eliminating node port local, or by using node port local to eliminate kube proxy and to bypass that. And that full suite of capability, power, analytics, and security is all available to you. All that resiliency, all that auto scaling, all that capability is there and available. Now, if you're using something like NSX load balancer or another load balancer, you can take that configuration and you can migrate that to Avi. Because if you're using another load balancer, it's not going to provide you that seamless self-service. Just upload the application on one end and everything magically works on the other end. Auto scale capacity, all of these things. Yeah, no. But you can migrate that configuration over to Avi. There's a tool called the Avi conversion tool, ACT, and it basically allows you to go and suck in configuration from other load balancers. It converts that to the Avi configuration. And then from there, it's going to go and spit that out into the Avi config, and we can fire that up on the Avi controller. So there's a lot of configuration, a lot of mess that if you're pulling in from other load balancers. There's a nice simple process to this. This conversion tool, it's going to go and convert that to the Avi config. So it's going to handle 90% of the workload right there, just converting that for you. And it's really cool because it's something that's got a nice UI on it. It will go and let you pick and choose. Do you want to do all of the config or just this virtual service and its corresponding configurations, and kind of walk you through the cutover and the cleanup. So you can do that complete whole process right there from this Avi conversion tool. It's something you can download, fire this up anywhere, and point it at your existing load balancer, fire it at, aim it at Avi, and away you go. So kind of in closing, if you look at self-service with VCF, the important piece is that self-service means that it's a complete, consistent, unified workflow. I want to be able to go and upload my application on one end, and it should just spit out on the other end, and everything should be working flawlessly as we expect. It's not something where I expect in the middle of all this, and then I have to go and open a ticket, and then another one, and then another one. If it takes you several weeks to deploy your new application, that's not automation. That's not self-service. That's right back to where you were before. That's the whole promise of VCF, is to be able to have that complete unified workflow and that kind of amazing experience that you can be offering, and still providing that same capabilities that you had before, that same security stories, that same, all the same robustness and same power, but be able to do that at the speed of business. And that's what Avi is all about. And that's what Avi with VCF is all about. If you want to learn more about Avi, there's a lot of opportunities here where you can go and take advantage of things like the VMUG Advantage program, so you can get your own personal use Avi licenses. You can join our workshops, and we have regular workshops for just kind of getting your feet wet a little bit. Or if you want to go and take the architecture workshops, you can get under the hood and really learn a lot and learn everything about Avi. There's advanced classes as well. There's hands-on labs for security, for AKO and Kubernetes, for just about anything that you're looking to get into. And of course, there's certifications. So feel free to go and check this out. Feel free to go and follow up with us. Hit us up if you want to learn and know more, and we're happy to go and walk you through this.